Hello everyone and welcome again to our channel. In today's video we have been asked to apply different search techniques of artificial intelligence on a graph structure provided to us along with a table of different values. Well, later we are going to talk about these values that are available to us and also the values that are mentioned on this tree structure. But firstly we need to know that what we need to do. We actually need to apply on this tree structure these four different techniques of artificial intelligence that we used while performing search to identify a path that can take us to a goal state. What are those techniques that we need to perform? First of all, we need to perform on this tree structure depth first search, then best first search, then a strike search, and then beam search with a beam length of 2. Well, we are going to start with the first one, that is our depth first search. Here I am not going to tell you about the algorithm that we need to apply on it, especially the theoretical part. We are not going to talk about it. But if you still don't know what is depth first search, I would recommend you to go and watch our previous video where we have studied this algorithm step by step in a very precise and detailed manner. But here I will tell you how you can apply this algorithm over this structure and what you can get from it. Depth first search, actually it is a searching technique that is also called brute force search or uninformed search. It means in that case of this technique we are not provided with any information whatsoever about our path, about nodes that lead us to the goal node. Here you see this value, these are for other search techniques. In case of depth first search, we don't need this table, we don't need those values. We are just focusing on those nodes that exist over here, because in case of depth first search we are not provided with any information. So let's move on directly to the algorithm. How we implement this algorithm? For implementing this algorithm, we basically need two different array structure or two different lists. One of them is called start. Another is called as close, or in some cases we just name it as a variable close list, or in some cases we name it as a variable k or start list. Okay, now first of all we start with the start state or the first state, that is s in our case here. So, and we put them this node here in our start list. So start list will become s with the existence of the first node. What we do in algorithm, we firstly give this value, the first node from the list, we give it to a variable that is k. Here I mentioned it. Now when k get this value s is deleted from the start list and is replaced by its child nodes. So what we have here, a and b. So now the value of start list will be, or the members of start list will be a and b. Next step, again we follow same procedure, and the value of k will be s and a, the first element of the list. And when a will be eliminated from the start list, it will be replaced by its children nodes. Now here interesting thing was, and it is very important to know that actually this our depth first search, it is called LIFO structure. That means last in first out. So it means the child of this a node will come at the beginning of the list. So a has two, which of them? Three actually, C, D, E. So it will come like this, C, D, E, and B will stay here at the end. And here we now, after again when we go to loop, this variable k will get a new value. It will be again the beginning of our, or the first element of our list. It was s. Now the start will get some new value after replacing C. Do C has some child nodes? Yes, it has H and I. So now again those two nodes H and I will come in the beginning of the list. As we mentioned earlier, it is a leaf structure. Then what will be the values of variable? It will get H value, and now new values of start list after replacing H. Since H don't have any child node, so we will move on to the next one simply. That was I. So here we have I, D, E and B, and here we have S, A, C, H. But now after removing I, the new start list will be something like this. I will be replaced by his child nodes that are L and M. So they will come in the beginning of the list, L, M. Then we have D, E and B. Now during next iteration, the new value of this variable or this closed list is SACIJ L. L will be removed from the start and will move to this closed list. Do L has child node? No. So it means we will just take a new loop and the new values of start list will be M, D, E and B, whereas K values will be S, A, C, H, I, L, and now the last and the first element of the start list, that is M. We'll get M here. Every time when this variable K gets a value, it is matched against our goal. Is it goal? If it is not goal, we continue. If it is goal, we terminate our search. And now in our case we get M, and if we see this diagram, M is our goal. You see these two different circles around it. It means that one is goal. So this is the path that we need to reach from start to our goal node in case of depth first search. I think this is clear. Now we can move on to next one, that is best first search. So now we will work on our next algorithm, that is best first search. Now best first search, actually it is also an kind of search algorithm in AI, but it is called informed search algorithm. Here we are provided information about different nodes of the tree. It actually means that we already know some information about the nodes that are on our way from start node towards the goal node. In other words, we are provided with a function that is called heuristic function. Heuristic function. For example, let's say fn, and the value of this fn is hn. Means h is the heuristic function of node n. So it means the value of a node here, that one is, that represent the distance of a node from the goal node. What it means that if we are at 8f, so approximately we need how much one cast do we will need to reach our goal. This is approximation, an idea that this is amount of cost that we need to reach our goal. So we are already here provided with. Here we need to be careful if we are provided with a diagram with values and a table also with values. In case of best first search, we are focusing on HFN. This is also called our future value, means the cost that we need to reach our goal, and we need to see where it is provided. But in our case, it is provided in this table HFN. So we are going to focus on these values, not on those one. I'm going to talk about them later in our next search algorithm, that is asterisk search. But for now, we are going to work with this one, those values. Okay. So now let's start with them. Best first search. What we do here is, here also the search expand level by level, just like in case of best first search. And here, as I mentioned earlier, that we have here function hfn. In this algorithm also we have similar, like upper algorithm, we have two different lists, closed list and start list, or we have a variable k that store values of the current node, whereas star list are contain the nodes that still need to be explored. Let's move on. First of all, start. What do we have here in our star list? We will provide it with first value, that is our starting node value s. Now after first iteration, the variable k is provided with the value of s, and it was matched against the goal. If it is goal, this value of k, it means we need to terminate our search. If not, then we need to explore its child nodes or successor, what we said then. What is important here? Here we need to see the cost of the nodes, and we need to sort them in ascending order so that get minimum cost from start to reach to goal. So first of all, we say, let's say we have we are working on this node s. So what are its child nodes a and b? Which of them has lower value? We are going to see over here. A is 2 and b is 8. So it means start will get a in the beginning and b after. Why? Because a has low cost value. So it means a will be explored first. It's also because it means that a has more chances to take us to goal with less cost. Okay. So now during second iteration, k will get value of a, and from start a will be discarded or removed. Now we will see the children of a. What they are? They are C, D, and E. Now we will again see their values. Which of them, and also the value of B. So the lowest one will come at the beginning. So C is 5, B is 8, and D is 11. It means we have C, B. Sorry, it means we have C, then B, then D, then E. So C, B, D, E. Well, it will be like this. C, B, D, and the node E. Next iteration. So we are going to take the first element from the list. This is for now C. So C is removed, and the start list will get the child node of C, and will be again performed the function of sorting to sort them in ascending order. So it means what will happen? C has H. So H has value of, here over case, 6. This is value 6. So it means this is 6, and which of them is less? 6, and also it has I. I is 5, so definitely is less than H, and also it is less than B, D, and F if you see their values over here. So here now we will have start list like this: I, H, B, D, and E. Now we remove again first element from star list. Let's move I. So as I mentioned that here we are left with start. C is replaced by I, H, B, D, and E were before them. So C is replaced by its child node. These were I and H. And here we have checked their values. I was 4 and H was 7. Then B is 8. So they come in the beginning: I, H, B, D, and E. Now during here next iteration, what we will get, if we remove I, and do we have child nodes of I? Yes, we have I child nodes. So start I will be replaced by still child nodes that are L and H, L and M, L and M. Now value of M is here 14. That is even more than the value of D. D was 11, so it means it will come after D but before E, because E is 18. And value of L is here 3. This is the smallest, so L will come in the beginning. L will come in the beginning. Then we will have H, then we have B, then D, then the second child from here we see M, 14, M, and then we have E, whereas the value of new value of this variable K will be I here. Now during next iteration, again then we will see L will go to here and we see do it has any child node. So K is equal to S, A, C, I and L. So L has a here child node? No. So it means we will not cannot add any successor of L. So we can just remove L, and the next will be H in next iteration. H, do H has successor? Do H also don't have successor. So when we add H here, after removing from here, we are also not going to get any more node over here. So we can take another time, another iteration. Now value of start will be B, D, M and E. Now if we take away the node B from here, the first node from this list, so here it will be S, A, C, I, L, H and B, and B will be replaced by its successor. If but if they are smaller in value, then they will come in the beginning, otherwise they will go to end. B. Now B has two successors that are F and G. We will see their value from here. G is 5 and F is 1. So it means they will come in the beginning because they are both are smaller than value D. So the value of start list will have like the new node sequence is F, G, D, M and E. Now next iteration, this time again we will remove F from here, so K will be like S, A, C, I, L, H, B and F, and in the place of F we will see the children of F. They are J and K, whereas value of J and K here, H and F values are J is 0, K is 6, so it is greater than G. So what we will do, we will put value. First of all, what we will see into start list, it will come the lowest value. Now in our case the lowest value is J and K. J is 0 and K is 6. The lowest is J, so J will come at first place. Then we have G. G is less than K, so we will have G 5. Then we will have K with 6, and then we will have same sequence D with 11, M and E. This is the sequence. Now again next iteration we will have values here like K is equal to S, A, C, I, L, H, F, B, F, and now we will have J. So J has any child node? No, so it means J can be removed like this and nothing change. It will just come here, it will stay same. G also don't have any child node, so G will be also part of K without including anything in this list because it is leaf node itself. Then K. Now K has child nodes which are N and O. Value of both of them 20 and 20. There are more than the values of all of them. So where they will come? They will come here. Now new list will be, let's write firstly values of K here. K is equal to S A C I L H B F G J G, then K, whereas replacement of K will come at the end of start list because they are greater. So value of now we have D, M, E, and N and O. Now we will remove D from here. Do D has any successor? D, no. It will just come here in this list. Next iteration we will remove M, so M will come also here, and we will see, is it gold? It is gold. So this is the big part that we need to follow in case of best first search to reach our goal, that was M. Now to find out the cost, we just need to add values of all nodes. Let's add them, where S is 0 plus A in our case is, from here we see values, okay, 2, then C is 5, I is 4, H is I is 4, yes, I is 4, I 4, then we have L is 3, then we have H is 7, then we have B is 8, we have F, value of F is 1, plus we have J, J is 0, plus we have G is 5, plus we have K is 6, D is 11, plus M is 14, because here now we reach to our goal. So if at the end, what will be the result at the end? Let's see, again S0 is 2, C is 5, I is 4, L is 3, H is 7, B is 8, F is 1, J is 0, G is 5, K is 6, then we have D, here is 11, and M. So on counting them, adding them together, we will get the value of our path, and this one we can count. Okay, so this was our best first search algorithm. Now we are left with another algorithm, that is depth asterisk search algorithm. We are going to do it in our next lecture.